we will use this framework to crack all the recent year CAT questions. Now, anything related with time would most probably come in the form of a word problem. And when there is word problem, there is a lot of information and there are a lot of question types that are possible. Luckily for us, in time and work, the means to give the information and the question type, these are the only two things that are going to have, a lot of subcategories. The solutions for most questions are going to be the same. There are only two methods to solve something, and more often than not, both of these will be applied together. So the three parts that we have broken this topic into is, first of all, the means to give information. Now, contrary to algebra, where you have one liner questions more or less, you will have a word problem that you will have to break. That breakage itself takes a significant amount of time. So what you should probably have is in your mind an idea on what type of information have they given to me. So the informations are broken into four certain categories. One is equation. They have given you something which will translate into an equation. The other is product. This refers to certain product that has to be taken. The most common in time and work is the ratio. So they give you the information in the form of ratio, and within ratio there is a subcategory of percentage. So as you know, ratio and percentage are the same thing, just that percentage has the denominator fixed as 100. Now, in the solution side, we will have two things. One is key movements. So now, in a word problem like scenario, very often you will find that they are going to be breaking the question into parts by themselves. This is what has happened. This is how the same thing has happened differently. Can you tell me what is going to happen if this configuration is used instead of the given first two? In this scenario, it becomes important to break down the timeline, make a diagram and break the timeline down so that we are able to use this information effectively. The most common method to facilitate this situation is going to be LCM method. We'll talk a lot more about this. Moving on, the types of questions that you can expect from this particular topic. There are five broad categories. Within this, most questions are going to be from this different work pattern. And what I mean by work pattern is the configuration used to do a said work. It could be you and me together, it could be you alone for the first 2 days, and then you and me together for the remaining duration, and so on. Most of the other questions, most of the other categories are a subcategory of this different work pattern. Block pattern is something where your work is getting repeated after a set duration. Rooster refers to a multiple people doing the same work, which are broadly categorized into certain groups. So man, woman, children, man and robot. So this would refer to a rooster configuration. Fraction of work is something which is a very particular way of asking a certain information. This usually ties back to your wages question, as we know that the amount of money you are going to earn by doing any work is going to be proportional to the work that you have done out of the total. And finally, there is something called as negative work, where there are some elements who are destroying the work done. So let's first look at the means to give information. Are you all clear on the roadmap? How the information is given to me? That is the first thing we will check. What is it that they have asked me? What is the question type? And then what is the solution that I'm going to use to get from the information to the question? This is going to be our pattern. So first of all, means to give information. So the equation format of giving information is very common, and the reason for that is obviously if they give you the information as an equation, the subtext is that that particular equation is something that you will have to make. So this way they are able to expand the word problem to include even more words. This would generally include some product of rate of work or time. This is usually given with the question category of different work patterns, where each equation will refer to one pattern of doing work. So if we look at this example from CAT 2019 slot 1, which was my slot, at their usual efficiency levels, A and B together finish a task in 12 days. So do you see how this is an equation example? They have given you this information that A and B can together finish a task in 12 days. This is an equation. Some of the things that you would probably write from here is that rate of doing work of A plus rate of doing work of B is equal to 1 by 12. This is one of the things that you could probably write. If A had worked half as efficiently as she usually does and B had worked thrice as efficiently as he usually does, the task would have been completed in 9 days. This is another equation giving you another information. You would write this, you would interpret this statement as rate of work by 2 for A plus 3 times rate of work of B is going to be what? 1 by 9. So this is what is meant by giving the information to you, uh, you know, uh, in the form of equation. Now, the rest of the part of this, certain question, it's a no-brainer, right? You just had to write these equations and you will be able to find RA and RB, and then you can find your answer. So this is one way of giving you the information in the form of a statement which translates into a certain equation. Something is equal to something. Moving on. Now the product aspect, uh, as a means to give information, it is a subset of this equation thing only. So it is rarely used, and it is used in a very uh, specific sort of scenario. For example, if the rooster type of question is involved, then they would probably have multiple people within a single group, right? You will probably have a situation like 3 men plus 8 machines. Then this 3 and this 8 gets multiplied to the rate of work that is given. So while here we took individual rate of works and added them because they were only one person, here you are writing the equation for a group, so you will have to multiply. Another sort of scenario here would be that they give you the time to completion in days, but they also give you how many hours they are working in the day, which means that the rate of work that you will use will depend upon the days into number of hours per day multiplier. So this seems trivial, I agree. But again, I've already said this is a subset of the equation format of giving information. So in this particular example, uh, water tank has two types of inlets, A and B. Uh, the empty tank is completely filled in 30 minutes if 10 inlets of type A and 45 inlets of type B are open. So, 10 times rate of work of A plus 45 times rate of work of B is going to be 1 by 1 by 2. 30 minutes is half an hour. So, we have written the equation, which is something we did in the previous slide as well. But this time we have multiplied the individual rate of works with the number of, workers. Here, that would be pipes that are included. You can then also write uh, the second equation as well. 1 hour if 8 inlets of type A and 18 inlets of type B are open, so that would be 8 RA plus 18 RB is equal to 1 by 1. Now after this, again it's the similar situation. You can find RA, you can find RB, and then you can find whatever it is that they are asking you. All right, can we move ahead? All right. Now, finally, to the ratio part, which is probably the most common way of giving information in this particular topic. Uh, Even if the information is not given directly to you as a ratio, generally you solve your equations to get these ratios. So maybe they are feeling generous, they will give you the ratio directly, or they will give you the equations, and you will have to convert that into ratios. Now this can be given in multiple formats even if it's given directly. So direct ratio of efficiency can be given, time to complete the work can be given to you as a ratio. You take 8 days, I take 10 days, which means our rate of work ratio is going to be what? 8 is to 10 is the ratio of time taken, then our efficiency ratios would be what? 10 is to 8. The opposite of that. They can give it to you like this. They can also give it to you in percentage. You are 25% more efficient than me, which means that our efficiency ratios are what? Again, 5 by 4. All right. So if you look at this example from CAT 2019 slot 2, Anil alone can do a job in 20 days while Sunil alone can do it in 40 days. So what have they given to you? Have they given you the ratio of their efficiencies? If Sunil does X work in a day, Anil will do 2x work in the same duration. So they have given to you the efficiency ratio as 2 is to 1. In the way that I have written this, you might already be feeling that ratio gets used a lot in the LCM method, something we will shortly see. Finally, the percentage method, again, it is a subset of your ratio thing. Uh, you know, uh, so this part we can ignore. So it is a subset of ratio. So this is just one example. The percentages can be given to you again as a direct ratio of your efficiency, or it can be given to you as a ratio, as a percentage of their original efficiencies. That my efficiency in this particular question from 2023 slot 3, my efficiency, whatever it was for Gotham, he's only doing 60% of his usual work on a day, which means that the drop in his efficiency is 40%. There is 40% of the work that he should have done, which he has not done. So, this percentage is again a means for them to give you the information. Again, you probably don't have to complicate it this much. For you, it could look something like equation or ratio. They will give you either the equation or they will give you the ratio of what that we have already discussed. Within equation they can give you product, within ratio they can give you percentages as well. And some questions, a sizable chunk would use both of this. The equation would also be getting made, and the ratio would also be something that is getting used after you solve the equation. Can we move ahead? Are we so far clear on this? All right, great. Now let's go towards the solution enablers. Let's first discuss the key movements thing. Now, first of all, this is something which is going to be there for time and work, time, speed, distance, mixtures, and any situation where you can make changes. So, interest, so most of your PLD also for that matter, most of your arithmetic would be predominantly based on this key movement concept, which means again it's a good thing, right? You learn it here, you can use it anywhere. So it's a highly useful concept in creating equations to solve. This is a enabler. It helps you make the equations. Now this is obviously going to be different from the equations which are given to you as a means to solve. This requires making a line diagram. Now, with time, and I'm sure a lot of you are already at a situation where you don't feel the need to make the diagram, but if you are even a tiny bit confused or the problem looks to have a lot of information, making a quick small diagram is always going to be very helpful. This diagram that we are talking about, this should include segmented by different rate of work. So whatever line you have made, you will mark key movements on this, let's say movement A, movement B, movement C, such that in this segment the rate of work is fixed. In this segment the rate of work is fixed. It can be different from the first segment, but it is fixed. It is not changing within A and B. Between B and C the rate of work is something else, but it is constant. And finally this, so this is segmented by the different rate of works, and each segment should have the duration and rate of work mentioned. So you will write the duration. You can depict it as the length of the segment, or in fact, and you should also have the rate of work mentioned. Now, for the rate of work part, what will usually happen is that for some segments you would have exact values. For some segments, some or all, you might actually write the rate of work using your LCM method, which we will quickly come to. Or your answer, the thing that you're looking for, could be the rate of work. So that would be an unknown and it would be a variable that you are planning to solve for. So this diagram, making the diagram helps a lot in solving questions that have a lot of information given. So if we look at an example, when they work alone, B needs 25% more time to finish a job than A does, which means that rate of work of B is going to be 4 by 5 times rate of work of A. Can I say this? So this is basically information is given to me as a ratio particularly as a percentage, and I have converted that into a result that I can use. They too finish the job in 13 days in the following manner. A works alone till the job is done half. So half of the work is done till now. Then they will work together for 4 days. So here you have RA plus RB. Here you only had RA. And finally, B will work and complete 5% of the job. So this is 5%. This was 50%, which means this is 45%. And the rate of bugs are RA for the first segment, RA plus RB for the second segment, and RB for the third segment. Now, after this, there isn't much left to solve. Correct? You already have this diagram. You now just have to start writing the equations. So making the diagram helps you break down the word problem where there are multiple, instances or scenarios happening, and then you can quickly make the solution equations, you know, using this particular diagram. Are we clear on this? We will go ahead and solve certain questions of these, but from recent years. All right, so let's finally move to the LCM method. This is always exclusively used. The LCM method is always used to define the total work as a convenient value. You can take the total work to be anything, and then you can, give other values according to the given ratios. But LCM method helps you put a convenient value on the face of total work. When I say convenience, I mean that there are no fractions that are getting involved in our solution equations. Generally, the LCM is taken of the time to complete the work. So, for example, if I take 5 days to complete a work, you take 7 days to complete the work, I will say that the total work is 35x, which means that every day I do 7x work and you do 5x work. So I took the LCM of the days, the duration it was taking us to complete the work, and then when I have this total work defined, I use that to calculate our efficiencies on a per day basis. No fraction is getting involved here. All right, this is extremely agile and it can be used in most of the situations that you will come across. If the ratios are given, then this would probably be definitely be getting used. I don't like to say 100%, but this is as close to it as it gets. If there are roosters, if there are block patterns, if fraction of work is asked. Now, when fraction of work is being asked, then obviously the denominator has to be defined, right? Which is the total work. So in fraction of work situations, LCM method will definitely get used. You will have to define the total work after all. Most of your different work pattern equations will also again use LCM method, and also for negative work. So again, something that gets used everywhere is again not something to be specially called out for. So what is it, where LCM method can fail? So generally, if there is an arithmetic relationship given between your rate of work, and when I say arithmetic, I mean plus minus, then LCM method probably will be difficult, because here I have given you the ratio of efficiency as 5 is to 7. What if I had given this to you as T and T plus 2? That I do the work in T days and you do it in T plus 2 days. LCM method makes very, counterintuitive sense here, because you don't have exact values, which would have been given to you as ratios. So what will you find the LCM as? Can you tell me what is the LCM of T and T plus 2 without knowing what T itself is? No, right? So in that particular instance, LCM method can fail. In my mind, this is, probably the only area where LCM method would not be getting applied. Now on to the question types. Now this is probably almost always present. So you can say that this is the generic question type for time and work. This essentially means that there are different work scenarios given to you. Now, think of it this way: the total work is something that is going to be fixed. You don't know what it is, all right, or maybe you do, doesn't matter, but it is something which is fixed. Now, they have to give you informations to put in this equation, let's say. Now, if they want you to get some information to put in this particular equation, they will have to define a scenario for you. One scenario to give you the inputs and the other scenario to calculate the output. And this is what I mean as different work patterns. So if you look at this scenario in the example that we have in front of us, let me zoom in a little bit. All inlet types of type B they bring together. So empty tank is completely filled in 30 minutes if 10 inlet pipes of A and 45 uh, pipes of type B are open. So this equation we have already written. This is your information equation. If you remember the ways to give the information, this is that equation, that you know 10 into Ra plus 45 into Rb is equal to 1 divided by 1 by 2. Similarly, they have given you another equation: 8 into Ra plus 18 into Rb is equal to 1 by 1. Now tell me this: in this scenario and in this scenario, is the total work same? Are these two things talking about the same thing? But they wanted to give me two equations so that I can find variable 1 and variable 2. This is what I mean by different work patterns. This is your work pattern 1, this is your work pattern 2. Corresponding to each work pattern, you get an equation, and finally, they can give you a third work pattern which you have to solve for, which is this: if this was 7Ra plus 27Rb, what would have been this denominator? This is what they are asking you for. That the time taken by 7 pipes of A and 27 pipes of B together. So this is work pattern 1, this is work pattern 2. Work pattern 1 and 2 are used to find the values of Ra and Rb, and then you will use these obtained values of Ra and Rb in the work pattern 3. Clear? Do you understand what I mean? Now, how you solve this, again, it's up to you. You can use this, you know, you can probably solve this using LCM method as well. Yeah, you can break it down. You can take it in terms of minutes. You can take it in terms of, liters. It's up to you. The point that I'm making here, I'm not solving this question. The point I'm making is the distinction between the work patterns that they can give you. Is that clear? Okay, great. Now, block patterns. This is again one of the most one of the easiest question that you can get, and this generally includes a timeline which is broken into segments where the rate of work. Remember, we were using the key movements thing and breaking the timeline into segments. The segments follow a sequence. The rate of work here, let's say, is A. This is 2A, and then this again becomes A. Then this again becomes 2A. So the calculation of total work, finding how many blocks I will be left with, becomes easy. So this generally has an iterative sort of statement going on. If you look at this example, first statement that I have marked here, what is this? They are trying to give you an information, and have they given the information to you as a ratio or as an equation? As an equation, they have given you three separate equations through which you will calculate the ratio of Amal, Vimal, and Sunil. Okay, actually till this place. Now, the situation that they have described for you, if Amal had started the task alone and worked on all days, Vimal had worked on every second day, and Sunil had worked on every third day. So it is going to be like this: Amal, Amal, Vimal, and Amal, Sunil, then again Amal, Vimal, then only Amal, then Amal, Vimal, Sunil. Yes, this is what they have given. So Amal is working every day, Vimal is working on even days, and Sunil is working on third, sixth, and so on. So after this, this pattern will repeat, correct? So this sixth day is what you will take as your block. And then you will find the total work that is getting done in this block itself. And then the total work that has to be done, you will divide that by the work done in one block. Whatever you get will be the number of blocks required, and each block is made up of 6 days. So your answer will be number of blocks into 6 days if if the duration is what they are asking you for. Clear on this? Any doubt? Now the rooster think multiple type of workers are present, or even if multiple type of workers are not present, you are working, you know, at a fixed rate of hours per days. So for example, in this situation, there are two working groups, humans and robots. So rooster would, obviously because there are multiple type of workers present, would always include the product in its, equation. So 15 humans and 5 robots working together. So you'll write this as 15 humans plus 5 robots. They are taking 30 days. Then 5 humans plus 15 robots. They are taking 60 days. This is 30 days. So this is the rooster situation. All right. They can further complicate it, have three types of, groups: men, women, children. All right. So now, obviously, through this equation, you will find the ratio between M and R, and then you will use the LCM method, or you can use the LCM method here itself, because you have 30 and 60. LCM is taken off what? The duration. You have the duration for these twos. So you can find the LCM of this, and then you can proceed according to that. You can define the work as what? The LCM would be what? 30 days and 60 days, right? So 60 would be the LCM. And after that, you can solve this. Now, a fraction of work. So, in your entire timeline of this key movement situation that we discussed, right? That this segment has certain workings, this segment has certain workings. They particularly tend to ask you about the fraction of total work that a particular individual or group has done. Now, if they are asking you for wages, fraction of work as a concept is always going to get used, because wages are decided basis the fraction of work you have done. Secondly, when you are writing the fraction, fraction should have a numerator and denominator. Denominator would always be total work, a quantity that you will have to define. And how do we define the total work? Through the LCM method. So, fraction of work works along with wages, works along with LCM method. You might not have wages, but fraction of work always will have LCM method getting used. So if you look at this example, Anil can do a job in 20 days, Sunil can do it in 40 days. After 3 days, Sunil joins him again. After a few days, Bimal joins them, and they together finish the job. If Bimal had done 10% of the job, so what you will do is you will make the timeline, uh, you know, so 3 days, Anil is only working. Now, after few more days, let's say X, so only Anil and Sunil is working. Afterwards, Anil plus Sunil plus Bimal, they are all working. Now, they have given that Bimal has completed 10% of the job. right? So which means Amal, A plus S and A plus S together, these things multiplied with their corresponding durations have completed 90% of the job, which is something then you can later on use to solve. Okay, just one more thing, negative work. Groups and individuals are involved that can destroy the work. And when that happens, you will have to change the efficiency, you know, take the same magnitude, whatever you would have done if it was positive work, and replace it with a minus sign. And this will always come with a DWB profile, different work patterns. So again, they have to give you the negative rate of work. How will they give it to you? Generally, they don't give it to you as a ratio, which means they will have to give it to you as an equation. And if they have to give you this in an equation, they will have to define, certain configurations of doing work. So for example, in this situations, in this example, 2018 slot 1 completely filled in 6 hours when 6 fillings and 5 draining pipes are on. So 6 filling minus 5 draining is what I will write. This is taking 6 hours. Now, 5 fillings minus 6 draining would become 60 hours. Now, obviously, 6 and 60, you can take an LCM, that is your solution enabler. These are two different work profiles, DWP, DWP. What is this? Negative work. So, you see how all of these three things, the way of giving the information, the solution enabler, and the question type is getting matched.